Should we start a? I'm asking as it's like we haven't planned it out. Should we start a welcome back? Here's the Tutor Wizard, all about chess. I see books about. I'm reading books on the shelf as I'm waiting. I always. It's funny when you have a wizard collection of books. It's like I didn't even know I owned a book all about chess, but apparently I'd read it at some point. I've had more math leak out my left ear than most people are ever going to have in their brain, and most people are like, yeah, I don't want to. So we're going to continue with the solutions to assignment one. And I'll put my coffee down, hold my coffee. This is a hold my coffee type of problem made by Mark. I'm going to guess, unless this B starts getting added down here, because we're going to have to do it, but this B specifically will never affect the solution. It'll be B plus 4, whatever happens when we get it. So it's on the right hand side, first of all, and this A will be more important. But what we're going to do is, what it's asking is, you put an A and a B in there and everybody loses their mind. So this is the first thing I wanted to talk about, where you don't have to reinvent the wheel. My original analogy is usually in calculus when we're coming up with it, but my two hammers, well, in any class, on all math classes, the hammer and saw, I have two tools in my toolbox, which they should show you. Maybe we should switch them to much more wizard type things. So I have a wand and a staff or something like this. Oh, there we go. And we just did it. Wand and staff. The wand is, first of all, when you multiply things, one doesn't do anything. And the thing you need with that, it's a two part. And then whatever you call it, B over B is one. So there's the wand. But the hammer and the saw is a good analogy, because whether I'm building a dog, cat house or a skyscraper, I don't reinvent hammers and saws. You're like, what should I do with this? There's an A and a B here is my point. So then now what do I do? You stick to the mantra of you augment the matrix, you row reduce, and you get to REF. Then you start making decisions about A and B. Just because there's an A and a B there, or what if I do this to you? Oh, now it's not. Now I put numbers back in. Guess what? When you start subtracting, guess what you're going to have to write? Pi minus 2. You can't get rid of pi. I am's who I am's. So just because it's an A and a B there, everybody panics and think there's going to be some magic new thing that we're going to do. No, we're going to augment the matrix and we're going to row reduce to REF, and then we'll start making decisions on the A's and B's that will give us one solution, no solution, infinitely many solutions is what it's asking. But back to this one. This is good for all classes, and you can use it anywhere you want in any equation. The staff or the saw is going to be with, this is with multiplication. With addition, A plus 0 is A, and B minus B is 0. And you use both of those when you complete the square, for instance. So whether you're completing the square or adding fractions or showing differentiability implies continuity. Can we remember those? I just wrote them. I just said them live on Twitch. But we're going to add fractions. We're going to complete the square. And we're going to prove that differentiability implies continuity. And you'll see that I use these two things as the trick that I use every time. These are the tricks you need to start memorizing and knowing how to use correctly to become a mathematician. This says that in a math equation, you can literally get something for nothing. And then I'll go back to this. So let's do this quickly. And they call it A's and B's because you focus on A and B. But now specifically, I'm going to change what it is, X, Y, Z, or X, Y equals Z. Okay? Talk about W in this equation. You're like, I can't. There is no W. Yes, there is. I just got W because I added 0. 0 doesn't do anything to it, and B minus B or W minus W is 0. So I've just got W in my equation now. Yay. Talk about U in this equation. You're like, there isn't a U. Yes, there is. U times U over U is 1. 1 times something is nothing. So I just got U and W in an equation where they weren't there before. This is the magic of how you get good at math. It's the hammer and the saw, or the wand and the staff. Whether I'm trying to transmute a toad. I've been watching too much Harry Potter. When you're trying to transmute a toad, Leviosa, levitatato. Whether I'm trying to do that or trying to get Voldemort, he who should not be named. She stole half of this from Lord of the Rings. You're not supposed to say Sauron, he who is not named. But okay, and it's the Jesus story. You know that Harry Potter is just the Jesus story, right? It is. It's the Bible story. But okay, don't tell anyone. Don't tell the heathen. But the trick in this is the same thing. And then students can't get these ones, especially the ones I'm going to throw Lorenzo under the bus because he's over there and they can't hear him because he hasn't plugged in his mic. He's like, I'll find the cord. but but when you get those 4x4 systems or those 3x5 systems, and they're huge, and they're row reduced, and the fractions are sevens and stuff like this, you're like, I didn't get it, so can I have another problem to try? It's like, no. The real lesson you need to start being told is by a wizard is that you have to keep doing that problem until you get it correct. The numbers were wrong, but you don't throw that one away and say, I guess I suck at math and do that. The difference between us, the mathematician, and the regular person is you try the question once, you got the numbers wrong, you're like, I can't do this, and you throw that one away and you look for a new one. No, it's the same one. It's like a wall. And when the wall stops me, I'm like, just wait. I'll be back with my sledgehammer or my hammer and my saw, and I'll get some new tricks, and I'm going to do the same problems. Stop looking on ChatGPT and the internet for a bunch of different numbers. The numbers have nothing to do with it. The method is I'm going to augment the matrix, I'm going to Gaussian elimination to REF, and then I'm going to make choices. If you stick to that, I don't care what the numbers are. I don't care what the A's and B's are. Rant over. So step one, augment the matrix. 3, -1, 2, B, 1, 1, -2, 0. Mark likes to put at least 1 0. 2, -1, A, 4. And I'm already shouldn't have done that because now I have to write it out again. But now we're going to the way that the student would, I guess. I'll go slow. I did that pedagogically for the student. But even as I was transforming it, this has a leading 1. I can recognize it even in this form. So I should have put that in the top row. It would have saved me on time on the exam. But I didn't catch it, so I'm going to interchange rows 1 and 2 to get a leading 1. The first mantra is get a leading 1. Try to use addition and subtraction using the Diophantine equations to get a 1 instead of just lazily dividing by 3. So then we have this, and then 2, -1, A, 4. There. Now what should I do? And if you do this mantra, get a leading 1 in the top left corner, eliminate below that. As soon as you've done that, then we'll have a 2x2 linear system. You get a leading 1, you kill below. You can't stop. You can't not. It's a double negative. I do it on purpose. You can't not know what to do in every step because now I know that this 3 has to go away and this 2 has to go away. And the reason why I like to have leading 1s when you're playing this game is because now I know that if I multiply by -3 in this row, I can get rid of that 3. And then I can use -2 to get rid of that 2. If you have a 7 there, then I have to multiply by -3 over or 7 over 3 to get rid. It's like, oh, I don't want to do that. I think I said it wrong even there. You can check back. Note in the comments that I said 7 over 3 instead of 3 over 7. What? You're like, I don't know what he said. It's one of those things. It's like at the end of the long expected party. I like half of you half as much as I should. It's like, what exactly did you say, Bilbo? I don't know what he said. I still don't understand. I still have a hard time unpacking what he said. We should unpack that logically. Row 2 goes to row 2 -3 row 1, and row 3 is going to go to, he permuted them to row 3 -2 row 1. So the first move is I'm going to multiply by -3. Mario's got to get out of the way. I pushed them down at some point. I was doing serious math, so we had to get rid of the Mario Goomba. Are they self-deleting? Yeah, they fall off the edge, right? Yeah, the Goombas and the green guys. The red ones are not. That's funny. YouTube is already getting me to hedge my words. It's like, but that's my choice. Self-deleting. You still know what I mean. I don't know why we need this double speak. But okay, I do want money. I am desperate for money, so I'll say it. I'll say it. S.A. Canola fields. Do you know what that joke is? Look up what they used to call canola. Now you're getting it. Now you see. Okay, let's go back to the math. 3 - 3 is 0. That's why I did it. It's a mantra in my mind. 3 - 3 is 0. That's why I did it. Now I have, let's see, I got to stop talking and pay attention and get my coffee because I made mistakes last time. It's okay to make mistakes. Do you see also last time, especially because it's the solution to your homework, I can't go, I got the numbers wrong. Just give me another one. No, I have to go back and make sure that the numbers are correct. Negative 1 minus 3 is negative 4. 2 plus 6 is 8. Okay, he's making it all even. And then, oh, I see why he did that, because the 0 won't affect it. And then we get b. B plus 3 times 0. Also, a times 0 is 0 if a is a real number. But infinity times 0 is an indeterminate form, because infinity is not a real number. But that's getting into either non-Euclidean geometry or L'Hopital's rule. Don't do real number algebra on things that aren't real numbers.
The guys in the help center are doing Mark's course on Euclidean, and it's great because they're going over everything that.
Oh, I can, let me update you. I'll send you all the solutions and everything. I have the PDF. I'll send you all this so you can preemptively read it and then have the answers meaningfully. Because when you do it in the learning center, you have to, if you're good at what you do, which Lorenzo is, but it's a complicated problem. You have to solve the problem in front of them, right? And you're not supposed to do that or let them. They're supposed to enjoy the joy of doing it themselves, or whatever bullshit they told us in the committee that you were supposed to do. But I disagree with this. It's a community type of problem, and you're not going to get all of them, and no one's going to be a wizard or a genius on their own. I've stolen all these good ideas from people like Mark Solomonovich and Vyacheslav Kasevich and Michael Lee and Lorenzo. It's like, how do I do freaking phase portraits again? It's like, I don't remember. It's like, yeah, I'm stealing it all from everybody. It's a discussion. Yeah, back and forth. So when we're doing this, you want to see, when you have the more complicated 341, which is non-Euclidean geometry, it's good to have the solution, read Mark's horrible thing, translate the way that he does it, because he's a wizard, and it's like it's cryptic because he's so smart he skips steps, and you're like, what's he doing? I'll just give you that notebook that I have. Remind me of that. I'm going to do it right here. The best part about reminders is I don't have to write the reminder. I have to write the reminder to open the door in my mind that there was something in that door.
That's more Harry Potter than Remember All.
Oh, is that? I haven't got there yet. I haven't seen them. That's why I started watching. I've only seen the first two, and then I think I fell asleep in The Prisoner of Azkaban. I had a small child at the time. You'll see when you have them. It's like, oh, we're gonna be in a dark room for 2 hours. Out, out cold. Okay, 2 minus. Now we're gonna multiply by negative 2. So 2 minus 2 is 0. That's why I did it. Also, that reminds you, when that mantra, that's reinforcing this. When I say it, it's subtle, but your mind will catch it. Now I'm stealing from Red Letter Media, Plinkett, but your mind will know, because I'm reminding myself of why we're doing this. I'm eliminating x from these two equations, and that's why I did the move. So 2 minus 2 is 0. That's why I did it. And then negative 1 minus 2 is negative 3. I can get a 1 from that by BT dubs. And then a plus 4 is what we're going to get. If you don't see that and you don't see what I'm doing, you can do, don't be afraid of side calculations. I'm doing a plus negative 2 times negative 2, which is equal to a plus 4. That's how I got it. I'm doing the side calculation, and this one is 4 minus 0, or 4, yeah, minus 0 is 4. All right. So now what? We're going to erase a little bit. And then, yeah, this is why I need at least one person. Otherwise, we'd be even slower, because whereas I need to go back to the chat. When I hear him typing, I'm like, there must be meaningful people in here.
We have a good group that comes and sees us.
Yeah, good. I had to put it down last semester because I was losing my mind slowly. It's still occurring, but I've damned it a little bit. I put some gum on the levee, but when the levee breaks, everybody, deluge. I'm not comparing myself directly to God, but Noah had to build an ark. Now what do we want to do? I need a leading 1. My mantra was get a leading 1. And then I want a leading 1 out of this. And I can see if I do negative 3 minus minus 4 will be 1, is what my brain is seeing. It's a Diophantine equation again. I'm doing negative 3x minus 4y equals 1. And I see if I use negative 3 times 1 And then negative 4 times negative 1, that will give me negative 3 plus 4, which is 1. So I found a solution. But this is the phrasing. Math is not mutually exclusive. Stop just taking this class and that class. And things that we're going to do here will definitely help when we do non-Euclidean geometry or number theory or any of these types of things. It's a twisted ball of yarn. And you never know when you pull at them when they're going to be connected. This is Dudonnet says this from Nicholas Bourbaki. Okay, so I'm going to do row 3 goes to row 3 minus row 2. And then when you're on an exam, you quickly copy out the things that you're not going to change. 0, negative 4, 8, b. And then now we're multiplying this, well, it's this row that we're using to manipulate row 3. So we're going to multiply by negative 1 technically. So minus minus. So negative 3 minus 4 is 1. That's why I did it. And then now this is where you can be careful because I'll get it wrong. A plus 4 minus 8 is what we're doing, correct? Yes, which will be a minus 4 this time is where that goes there. And then now we're doing, oh, and then it's going to be b minus 4 also. Weird. Don't look for patterns. Don't second guess yourself. If those are the numbers, I don't know why Mark put a 4 there on both of them, but c'est la vie, c'est la vie. Now I have a leading 1, which that 4 won't be used in my solution anyways, will it? It might be. We'll see. Don't start predicting. Don't start predicting. Now, what do I have to do? Oh, I just erased it. Son of a bitch. No, this is the one we got, right? Yeah, okay. I was like, oh no, did I just erase the one we had? Zip, zip, zip. I need to go look back on the stream. Now we're going to interchange rows 3 and 2. I'll just write it here quickly. 1, 1, negative 2, 0. 0, 1, a minus 4, b minus 4. And then 0, negative 4, 8b. And so now, like I was saying, I'm not looking at this at the monitor. I keep looking at this, but it's not that. It's that guy. It's Rick. You can't see it, but Lorenzo put a face there, said I would look at Rick, and I still just tend to look at myself because I'm a narcissist. So I need to get rid of the 4. You can't be stuck. So I'm going to do row 3 goes to row 3 plus 4 row 2. We're multiplying this one by negative 4. And so let's see what happens. I get 1, 1, negative 2, 0. 0, 1, a minus 4, b minus 4. Okay, I see why the b minus 4 won't help us, except for now. Now I'm doing 4. It should be plus 4. Yeah, plus 4, I got it right. 4 minus 4 is 0. That's why we did it, not 6, 0. And then now what do I have? Okay, crap. So now we're doing 8 plus 4 times a minus 4. Do you see? Don't try and do it in your head. Mark's a genius, and he always does. And it's like 1 minus this is 0. But it's like you don't have to mimic what he sounds like, but you can if you want. And now I have to do multiplication, which scares me. 4a minus 16. Okay, that's not so bad. So that'll be 4a minus 8, which is, I need to know what a is anyway, so we're sharing sheep, but I'm going to preemptively, it should be a 2, not a 4. So, and then I factored out a 8. What I'm seeing is 8. You need to start doing number theory. When you know number theory and you know that every composite number is a unique product of primes, I know that that's 2 times 4 is what I'm seeing the 8 as, and then I can take a 4 out of both of them. And that's what I have. So what do I have here? 4 times a minus 2. And then here I have this. We're going to still do this. So, no, it's this move. So I have b plus 4 times b minus 4. Is it the same calculation? No, except for the b. So now I have b plus 4b minus 16, which is, fractions, 5b minus 16, right? If I did that correctly. Yeah. Normally I would say I don't care if the numbers are not that, then just go use ChatGPT. Never use ChatGPT, but use Desmos, says Lorenzo. I almost called you Mark. You're like, I'll take it.
If I ever get to that level.
You're getting there.
Not at this point. I'm 40 and still.
You're never going to touch it. They're asymptotes. He's an asymptote.
Oh, I see.
I'm going to tend arbitrarily close though if I can. That was another math joke. Never mind. So now we're going to make decisions. This is REF. And now you can see why Mark says don't worry about getting a leading one in REF, just get a leading entry. But now this will give us cases. So the first case I'm going to use is case 1. I'm going to assume that A is not 0 so I can get a leading 1 because I want 1s there. So case 1, assume that A is not equal to 2. That means that in that assumption, now this means that this guy, I'm also going to move this up so I can do the cases over and over again. And what I'm going to start doing is, again, Mark is a genius, so he's just doing it in his head. But I write out the REF for each case so that I can see it. And so then this is much better for the student. So first of all, I'm going to write 1, 1, negative 2, 0, 0, 1, A minus 4, B minus 4, 0, 0, 4 times A minus 2, 5B minus 16. You could do an operation where you divide by 4 if you want. I'm going to do that, but well, I'll just leave it. Okay, that was not necessary, but it made me feel good. So now that I've made the a priori assumption that A is not equal to 2, that means that 4 times A minus 2 is not 0. I'm checking that Mark's lightning bolts can't strike me down, so I can divide by this guy. So now that I've made that assumption, my REF is going to look like this. 1, and then I can divide safely by A minus 2 because I've assumed it's not 0. And then now I can say, did I have to make, so first of all, this bothers the student at first, but did I have to make a restriction on B? No. So B can be anything. So case 1, if A is not 2 and B is any real number, I have in REF, I have the same number of leading entries as I had variables originally. So that means I have a unique solution. This is what we're trying to train you in these types of problems. I don't really like the weird, clever games a lot of the time in math because it just it confuses the student. But these ones, Mark also keeps in the book because he doesn't like this either. And it's actually pedagogically doing something extremely important. There's only ever 0, 1, or infinitely many solutions, which is all you need for the unit step function and delta Dirac function, coincidentally also. But you need these 3 things. You can build almost anything from those 3 guys. All of numbers from that guy. But what we want to know is assess, do I have no solution, 1 solution, infinitely many? When do you make that decision? For all intents and purposes, I didn't even need to know what that is. I didn't need to know what that is, and that's, I stole it from Mark too. He just put stars there because it's not affecting the decision is why he's telling you that. He's reinforcing the fact that none of those numbers have anything to do with my decision-making process. The last row in REF, with a couple caveats, for all intents and purposes, will tell me that over-determined system last time we did get rows of zeros, but you might have a unique solution even though you had a row of zeros. We'll do one at some point when we do the adding fraction business, etc., etc. We're going to stream every day this week. So if you're here, we're going to try and stream we're not going to try Yoda, you're right. Do or do not. There is no try. So we're going to stream. Do I have a Yoda handy? I took it upstairs. He's around here somewhere. I've got one in that room over there. I've got all the different ones. I like the Yoda that I like that looks the best in Lego form is the Clone Wars Lego Yoda. Anyways, that's how my brain works. This one, if A is not equal to 2 and B is any real number, we have a unique solution. Then it's like, well, what are you going to do? Well, we assumed A wasn't 2, so now we're going to assume, oh, it's alive. Oh, or is it Tim? I thought it might have been Mabel, the daughter. It's alive. Don't make eye contact. Feed it some blood sugar. You need to get her blood sugar up. But I think it's Tim. Tim sneaking in, but he's deaf, so he can't sneak as good as he used to. So it's Tim. Case 2. I hear lumbering giant. I only drank half your coffee. It's over there. No, I'm just kidding. Oh. I tried, and Lorenzo said it's only 1 is for me. Okay. I was like, he's late, though. He forfeits it. Yeah, that didn't work either. Lorenzo's got your back.
Forfeit. Your favorite. For and fit are your favorite 2 words in the English language.
Yeah. 2 plus 2 equals 2 times 2 equals 2 to the 2, which is the date of my birthday in February. 4. 2 plus 2 is 4. Barney had some of it right. He didn't have the family stuff down. You love me, I love you. That's not commutative. That's not commutative, you jerk. There's no guarantees there. He had the math down, so we'll keep him. I just picture the sad drunk dude inside Barney. Like the sad drunk dude inside of me. I gotta stop drinking right after I make jokes to make myself laugh.
Just blow coffee out your nose.
I tried, yes. I just
Monitor all of it.
yeah. Yeah, I tried. I just about did. Case 2. If A is equal to 2, then 4A minus 2 is 0, and then we have a problem. So I'm going to use this, but now under that assumption, I'm going to write down 1, I don't care, equals I don't care, 0, 1, I don't care, 0, 0, 0, and now I have 5B minus 16. Okay, I was pretty sure Mark wasn't going to make the A and the B the same numbers, and now I have confidence in him again. Okay, I never lost confidence. But now you can see now we have to, under this now overcasting assumption of A, it's going to split into 2 cases in B, which everybody hates and has to. I also had Mark for linear algebra 120 and 115 and 225 and 241 and 341 and 228. Yeah. The devil's in the details. Once you find a guy that's going to twist the knife, take it again. Pain is weakness leaving the body. I did the same thing at the U of A with Volker Runda and George Peschke. It's like, oh, those guys have a reputation for being nasty, hard stuff. It's like, we're taking those ones. All of them. So I took as many classes as I could with Mark Solomonovich. And when you can, at first you're like, oh, I don't like this subcases. So don't carry them around in your head. Under this assumption that now A is 2, I have 2 cases on B. B is equal to 16 over 5, or B is not equal to 16 over 5. Because I want to know whether this is 0 or not 0. So which one do you want to take? Oh, now I hear a cat coming down. There's a cat perched right above me, I swear, or I'm losing my mind.
Inclusive
Inclusive. Inclusive. You're malicious and a half-wit? Oh. Either you knew or you didn't know you're ruining my life. Either you knew or you didn't know you're ruining my life. I want to do that card game again. Let's do that card game in front of everyone. We'll get Tim up here in a second. I need to. Okay. Oh, you got to say a bunch of K's. 1 K is okay. K is okay. 3 K's is too much.
Back to 4, you're all right.
Back to 4, it's okay again. Same as the Waffen SS. 1 S is okay. 3 S's is you're a snake. Snake is snake. But 2 S's is you're the Waffen SS. Don't do the salute at the same time you say Heil Hitler. You know, one or the other. Stop sound biting me saying that.
And all of these now belong to these.
And now we have 0 viewers and subscribers. All right. What was I doing? Tim came in and I had to show off for a minute. So then, okay. 2 cases. Let's do, everyone's a ground optimist. So let's do the consistent case where this is equal to this, which means this is 0. Under that means 5b minus 16 is equal to 0. And then now you can see under case 2, if A is 2 and B is equal to 16 over 5, we get a row of zeros. And now you can see in the last row of REF, I make my decision that we had infinitely many solutions. Notice that luckily, especially because Mark gave me fractions, I like math, but I don't really want to add all those fractions. I'm not going to back substitute up and find out what the numbers are, but you can put them in there because A and B have definite values and you can find the infinitely many solutions. Who's the free variable? BT dubs. You can tell without knowing any of the numbers. The column that didn't have any leading entry, so Z is the free variable, and you could backtrack up. That's the difference between assessing what kind of solution I have and giving me the solution or solving the system. When Mark says solve the system, he wants to know what the solution looks like or the solution set, and there's infinitely many points in there. But he didn't ask me that, so I'm not going to do it. I'm lazy and a mathematician, so I'm going to do exactly what he said. In this case, we have infinite many solutions. Also, there's a couple of them in Mark's book that we should do where he doesn't give all three cases. So don't be tricked into thinking just because you row reduced it that there has to be one case where you're going to get one solution, one case where you're going to get no solution, and one case where you're going to get infinitely many. Because sometimes he has ones where he's cooked up with where no matter what the A and B are, is there's a unique solution or no solution. There's no case where there's infinitely many solutions. So don't just start mimicking and becoming a pigeon on a stool. Use your thinky brain and assess what's happening in each case. I'll digress. And now we have this case 3. Still has to be that the A is equal to 2, but now B is not equal to 16 over 5. And we're going to get in this, well, I won't do it. Let's rewrite it out. Case 3 now says, if from this I rewrite out what the new augmented matrix would look like under this a priori assumption now. This would be 1, 1, negative 2, 0, 0, 1, a, I don't care, I don't care, I don't care, I don't care, I don't care. Now it's 0, 0, 0, not 0, which means no solution. You can write that out, but it's b is not equal to this, so this is 5b minus 16, which we've assumed is not 0. So what that says is everyone forgets to write this as an equation. You don't mind taking the original system and augmenting it into the matrix, but I find this strange phenomenon that once we get into that and we do the Gaussian elimination, the whole point was this is an easier system, which is what we call equivalent, so it has the same solution set. So that says 0 times x plus 0 times y plus 0 times z equals 5b minus 16, which we've assumed is not 0, but this is 0 plus 0 plus 0, and it doesn't matter where you put the brackets because it's a vector space, and so that says that that's equal to 0. So that says 0 doesn't equal itself, and I disagree with temporary insanity. You're always equal to yourself. This is the reflexivity property of an equivalence relation. Equals is an equivalence relation. Where is my mind? Next. So that's number 3, right? And there was one. So I'm looking for, I've got frickin' coffee in my nose. It's my fault. Find, oh, now he's saying find the general solution. Damn it, I was just saying I don't have to, and then Mark got around me. So just a second. Yeah.
Same sort of idea.
Yeah, again, are we going to reinvent the wheel? No, but you'll see right now. In that one, I got away with just telling me what kind of solution I have. But in this one, he words it specifically by saying, don't do that. And that's why he started doing that. He also is lazy and jaded and really just doesn't want to do it anymore because he's 20 years along further than me even. And I feel his pain now. No good deed goes unpunished. But he's given you 3 and 4 specifically because he wants you to tell the difference between telling me what kind of solution I have and giving me the solution. Einstein said that, right? We're really good at solving the problem at hand, but not predicting the new problems that arise from that. I can turn energy into mass. It's like, uh-oh, whoops. Oopsie. Oh, he gave me a homogeneous solution at least. Okay, a homogeneous system. That's good. What? I like secrets. All I can hear is your whispers. You're going deaf, your whispers.
The LGBTQs.
No.
Okay, go back to a whisper. Go back to a fucking whisper. I'm trying to keep my job for the next year.
Have the kill switch.
Okay, guys. Tim's going to go find the microphone and plug it in. Having said that, I will not silence you, Tim. I will just not condone what you're saying. But you can say whatever you want. I'm not a zealot. Well, wait a year or so, and then we're going to discuss a lot of things.
That's better.
Horse before the cart. I'm the king of France. I'm the king of France. Still not the Dauphin. That's as far as I'll go with it.
Dinosaur does linear algebra. Wow, there's a Barney episode I pay money to watch.
There you go.
What the frick was the show after Mr. Dress Up? It was My Friendly Giant. I don't know what he's smoking, but he's in a castle and there's a giraffe that walks up into the thing and it starts talking to him. I'm like, I wanted some of what he's got. Fucking, even as a kid, I'm like, why is there a talking giraffe at that guy's window?
Well, the guy behind the scenes only had two hands. He's got one hand up the giraffe, and the other hand up the rooster. So.
Oh, it was a rooster. I was fixated. I didn't even know that there was another animal in the room. I'm like, there's a talking giraffe. What's going on here? Why is there an old man saying, come in here, little kitty, the Mr. Dress Up right before it? Okay, he was all right. He was a...
Maybe for our American audience, explain that Mr. Jessup was the Canadian Mr. Rogers.
Okay, oh yeah. Go watch the Eddie Murphy version of Mr. Rogers. Have you seen that? Yeah. Oh, go watch Eddie Murphy do Whiteface. It's hilarious.
I will, yes.
Oh, that's so good. He goes into the store and they start giving him stuff for free and stuff like that. Oh, you're a white guy? Here, you got some stuff for free. Oh, good times. Whiteface, I said, not blackface. Whiteface. You're allowed to do that. It's not racist. Okay, Tim's here and he got me off track. Row 2 is going to go to... I'm going to go back to solving this linear system. It's safer that way. Row 2 minus 3 row 1. And then we're going to do row 3. Go through row 3 plus row 1. From Smurfette, that bitch.
Oh, you heard that.
I told you, your whispers aren't as whispery when you're deaf. Sing, shots fired, shots fired. You can't control that anymore. I can control being a dickhead. Know thyself, know thyself. Okay, copy this out. 1, -2, 1. I like doing this much more. I just need to get monetized so that I can make this a day job. I feel happy again doing math, almost.
That's the right direction.
Yeah, 3 minus 3 is 0. Oh, I've done this one before. 1 minus 6 is 7. I sort of recognize this, and then we're going to do negative 3 minus 3 is -6, and then the zeros won't change. I copied them down. That's why he gave us homogeneous at least. There's got to be a row of zeros in here, or he's going to make it to be a row of zeros, or there won't. Is this the one where I just said it, where there's no just wait, I'll get there. I'm predicting now. I'm like, it is the one where there's only, because there's only one A, there's only 2 choices, so there will never be a unique solution. There can only ever be no solution or infinitely many, or we'll find out.
Yeah, unique or infinitely many.
Okay. Yeah. Lorenzo's been in the help center, so. In the trenches. You thought I was doing you a favor, but I'm like, I don't want to do this anymore. Lorenzo! We're going to add -1 plus 1 is 0. That's why I did it. A minus 2. And then get that out of there. I'll look at it. -4 plus 1 is -3. Okay, good. Now, this is where sometimes I say, work smart and not hard, but if there are fractions in the solution, then there's fractions in the solution, and we have no choice now. There's nothing I can do to that without manipulating that and going backwards. To get a leading 1, I do have to divide by 7. So I've got a leading 1 now, and now what I would want to do is, how do I get rid of that guy? I see why Mark does that. So suggestions from the... Is Tim looking at the screen? How do I get rid of that? We're going to do row...
I was trying to, be less divisive.
Don't change who you are. Never apologize for who you are. I'm unapologetically me.
I'm sorry, I'm so unapologetic.
Give the narcissist answer. I'm sorry you feel that way. I'm sorry you feel that way. So this one's a little bit trickier too. I see why Mark put it there, because now I have a 1, but I want a 0 there, and the A is going to move to here. But how do I do that? 2 minus A. What cancels A minus 2? Negative. So we're going to go to row, I'll write it out. Row 2 goes to row 2 plus negative A minus 2, which is 2 minus A. Row 2. So we're going to multiply this one by 2 minus A. I remember catching this. He caught me with that, caught me off guard with it the first time because Mark's so much further ahead of us. He's 2 steps ahead every time. Possibly because I'm drunk and I've got 1 step forward and 2 backwards, but let's do that. So now what are we doing? We're doing that move and we're going to get to 1, -2, 1. At least those don't change. And then I have 0, 1, -6 over 7. And then now I have to do it 0, and that's why I did it. But now in this spot, I have -3 plus 2 minus a times -6 over 7. Don't be shy doing side calculations. So now we're going to do distribution from the left because this is a vector. The real numbers are a vector space over themselves. So this is -3 minus 12 over 7 plus 6a over 7. Don't be afraid of the fractions. How do we do this? I'm about to use the wand. I need a 7, so I'm just going to multiply by 7 over 7. Tim. No, you're the construction guy. I'm like, this is wobbly. Mr. Fix It. I know, I'm just bugging you. Oh, hi, Lara Croft. Right next to Dave Mustaine shredding on a double-necked flying V. Can you see that in the shot? No? You can't see the double flying V. He's got a double neck flying V. Is there actually? Okay, there is 12 strings on there. What does he use 12 strings on? It looks like he's in... He is. You can see it behind. He's in Holy Wars era. He wrote that in getting kicked out of a pub in Ireland, and that's when he wrote, because the IRA was there, and that's when he wrote Holy Wars. Oh, shit. Yeah. But anyways, sidetrack. This was, oh, now I have to add numbers and multiply. 12 plus 21, is that a 33? -33 over 7 plus 6a over 7. So that's what we get here. I can take a 3 out of those, which will help us a little bit. That looks like 69. That's A. Nice. We need the imaginary one. Square root of 69i. 8 something. -69. There's a joke in there somewhere. All right, so now what? Oh, is that what he says? Let me go back. Okay, good. Lorenzo's on it, but this is good advice. Go back to the question when you do a calculation, especially when it's long and hard. Oh, there's an entendre there too. And reassess what they were asking me. You have orgasms too? Find all values of A for which the following homogeneous system has non-trivial solutions. Non-trivial meaning non-zero. He likes to say trivial. Find the general solution in this case. So I don't have to do the other cases, but let's just rephrase it a little bit. So there's only going to be 2 cases. If this is 0, then we have a row of zeros. So if 6a minus 33 over 7, which is 3 times 2a minus 11 over 7, is equal to 0, that means we have a row of zeros, and that tells me a is 11 over 2. And then that will give me a row of zeros. So if a is 11 over 2, that's not so bad. Now that I have that, so my case is, if a is 11 over 2, you can see it disappears. There it is. You can see, what do you guys, now you guys are writing stuff down so I can't hear you. Damn it! They're on to me. Oh, the chat. Okay, what? We don't care. Was that? Oh. Wait.
Was that one? Was that the nasty one?
Okay.
That's your next question.
Who cooked that up? The U of A?
Yeah, and that's 125.
See, this is the arms race that they're doing. They now insist on staying an education system, not a learning system, and they want to play blah, 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 blah. So they're starting to make, they know that there's ChatGPT, so they're making it horrible so that ChatGPT can't get around it.
So just so everybody, it's nasty bits.
Get closer to Adrian, he can't hear you.
Oh, sorry. So
he's leaning right into his chest.
So it's kind of nasty, but it's not bad. I worked it out. It collapses quite nicely. So if we talk nice, maybe Adrian will show us what's up.
Yeah, we'll do that one next. Oh, do I have to be a chauffeur today? No, she's got the day off. Tomorrow, it's like, she's like, I got tomorrow. She comes in, 17-year-olds. I got tomorrow off too, Tuesday, but we have jazz band and it starts at 9 a.m. I'm like, oh, that's not the day off. Any statement before a but is relatively meaningless. All right. So if A is 11 over 2, then you can see we have, this is REF and we have infinitely many solutions. But now Mark said as the second follow-up statement, find the solutions in this scenario. So I say so a lot. We started editing them out at one point because we noticed it, but that's okay. Therefore, it was Z. So Z is free variable because this column has no leading entry. This one does, and this one does. So we know Z is a free variable. So if Z is free, we have one of them. Now this equation says 1 times y plus negative 6 over 7 z, but z is t equals 0. So that says y is 6t over 7. This is a line through the origin. No, not through the origin. Possibly. Let's find out. And then x is equal to, I'm already bringing it over to the other side. I'm being, okay, I probably shouldn't be lazy because this is the solutions. X minus 2y is the same equation. Plus z, it didn't change to get to REF, is 0, is what that one says. But now we know z is t, and we know y is 6t over 7. Oh, it is a line through the origin. Just a second. Also, I'm going to add 0 3 times to show you. I'm going to use the staff now in a second. Even in linear algebra, it's useful everywhere, and that's why you can't see it. So this is what? This is x is equal to 12t over 7 minus t. So let's use the first one. I'm going to multiply by 7 over 7. I'll use the wand. Where's my Voldemort wand? Yes, I picked the bad guy's wand. It looks the coolest. I don't know where I put it. It's over there somewhere. No, it's over. I don't know where it is. I'm not going to start looking for it. I thought I put it up here. Oh, there's a spider web over there. I put my hand in spider web. I think it might. I don't know where it is. It's organized chaos. Everything's where it's supposed to be. I'll find it later. Let's do some scroll. I have some scrolls though. Nerd of the Rings. Guess what I used to do when I had no friends when I was 14? Draw maps of Lord of the Rings. It's upside down. Just wait. It's fading now because this was made in the 90s. I have no friends. Why do you think I got good at math? No one would talk to me. 12 minus 7 is 5. T over 7. Oh, Willa likes Lorenzo. So this says that x is 5t over 7. So now what that says is the infinitely many solutions are x. Let's make it in vector form, because Mark would do vectors before he does matrices anyways, or these linear row reductions possibly, the way that he wants it to be done. So this is x, y, z equals, now what did we get? X was 5 over 7 times t. Y, hi, 6. You're even going to come and see me? Get in the camera. She knows what's up. Don't run away from me. I know. She tried to run. She tried to run, but I caught her. Hi. Everyone loves you, and they want to see that we actually have cats. Or I've just been talking to myself. I don't know which one's better, that I'm talking to you and expecting a response, or just myself. I know you love me. You can't fake that kind of stuff, though. Somebody likes me. You want? You want Lorenzo? Okay. So there's the vector, but now can you see? You're like, how did you know it was through the origin? Because this is the parametric equations of a line in 3 space, and there is no constant vector. So that's 0, 0, 0 plus 5 over 7, 6 over 7, 1 t. So now this solution, which is infinitely many, it's infinitely many because it's the line through the origin in the direction of that vector is the solution to that linear system when A is 11 over 2. That's what's happening.
So, all right, that's another 2. Do we want to take a quick breather, then you and Susan do the other stuff? And I'll do
Yeah. I'm gonna throw Tim under the bus, and he can write it on the board. I'm gonna sit down and I haven't.
So sign off for now. We're going to say bye. We'll be back in a few
Okay, bye. I'm gonna go breathe because I haven't been breathing. I've been talking a lot.
You're breathing.